A very interesting question we have here. It says a uniform meter rule balances on a knife edge at 55 centimeter mark when a mass of 40 gram is hung from the 95 centimeter mark. Find the mass of the ruler. So this is the uniform meter rule. We are told that it balances on a knife edge at 55 centimeter mark. So we have a knife edge 55 centimeter from the start of the meter rule. The meter rule was balanced on the knife edge. Then a mass of 40 gram is hung from the 95 centimeter mark. So here we have a mass of 40 gram hung from 95 centimeter mark. So if this is 55, then obviously if you add 40 centimeter to it, it will give us the 95 centimeter from which the 40 gram mass was hung. Now the question says, find the mass of the ruler. Before we indicate the position of the mass of the ruler, I want us to understand the concept of center of gravity. This is a concept I discussed in our previous video. So if you've not watched that, you want to go and watch that. For a meter rule that is uniform, as in this question, the center of gravity is at the 50 centimeter mark, which means the mass of the meter rule, m in this case, because that's what we are calculating for, let's call it m, will be 50 centimeter from the beginning of the meter rule, or will be at the 50 centimeter mark. That is because it is at the center of gravity that the entire mass of the ruler appears to be concentrated. So if we are looking for the mass of the ruler m, then that mass should be acting at the 50 centimeter mark, which is the center of the meter rule. And of course, the meter rule is uniform, so it should correctly be the center of gravity. Now we have all the masses and distances set out. I think we are missing one. If this is 50 centimeter and from here to this point to the knife edge is 55, it means from the mass m to the knife edge will be 5 centimeter. So now we have all the distances and all of the masses in order. Now let's look at how moment will play out. About this knife edge, which will be the turning point, the mass of 40 gram will create a turning in the clockwise direction about this point. So we can call this moment clockwise moment. On the other hand, this mass about this turning point will create an anticlockwise moment. So let's call the anticlockwise moment ACW. Of course, for this meter rule to be balanced, we know that the principle of moment says the clockwise moment must be equal to the anticlockwise moment. Looking at the clockwise moment, we have the mass times the distance 40, which is 40 times 40. Guys, I did not convert the units to the SI units because gram and centimeter still works so long these are the units that we used throughout the work. We are okay with it. Whether we convert to the SI units, kilogram or meters, we are still going to arrive at the correct answer. So we are better off keep it simple by leaving them in this centimeter and grams units. Nothing has changed. The units will cancel out correctly. If one of the units was meters, while we having centimeter in some, then we have to convert to a common unit. But now we have centimeters and gram. So our answer will also come in gram because we are looking for mass. Having said that, we have that the clockwise moment will be 40 gram times the distance to the turning point, 40. 40 times 40 equal to the anticlockwise moment will be the mass m times the distance between the turning point and the point of application of the mass, 5. That is m times 5. To obtain m, we divide both sides by 5, and that gives us m equals to 40 times 40, which is 1600 divided by 5, and that gives us 320 gram as the mass of the meter rule. It is very, very simple, and I believe you enjoyed it. So now try this simple one. It says a meter rule is found to balance at the 51 centimeter mark when a body of mass 70 gram is suspended at the 10 centimeter mark. The balance point is found to be at 25 centimeter mark. Find the mass of the meter rule. Please put your answer in the comment section, and thank you for watching this video. Endeavor to like and share this video, and hope to see you in our next video.